I don't have the option. Okay, you started it. Thank you. Okay, so so today is our engineering sync up. Um, first, I want to so the plan for today is first I want to figure out where we are in terms of developing our demo. Um, Again, I want to reiterate that this demo is a development milestone for us, where we want to show a demo once we have developed the product in a production ready manner to a certain extent. So for this demo, we want to show a simple greenfield provision bucket or create bucket, and grant access for that bucket, and put that bucket into a pod. These are the three use cases. And we're nearing the end of the year. So one of the things I want to figure out is if it's possible to hit this milestone before, say, the second week of December. We are very close. But there are a few new things that have come up. Like we are migrating our project to the Kubernetes SIG repo. So one of the things I want to clarify today is the migration plan for that. And then once we have a picture of that, we'll have a clear idea of when we can hit this demo milestone. So this is where we were in terms of development last week on the 26th. The tasks in green have been completed. The tasks in blue do not apply for this demo. And the tasks in orange need to be completed. So I want to go to today. I want to start with the central controller manager. So Srini, where are we? I think these two have been finished, right? Bucket request, update, and delete.
Sorry. No, they're not finished. I have to still do those too.
Okay.
But it's not a whole lot of work. I can do that, but currently I'm trying to do other things, so I kind of put it in the back burner. So.
Okay. Yeah, I understand you're working with moving the code from our temporary repo to the actual official ones. So I think that's a higher priority. So that's fine. Is Rob on the call? No, it's okay. So Rob made another PR this week or last week, and that was about fixing some updates in the sidecar controller, where when a bucket is created, he added code to make sure that things like region and zone were passed into the actual backend. So that reminds me. So Srini, you made a pull request to the upstream API repo, the official repo, where it looked like we had added a few fields that were not in the KEP.
Right. That's there are a few things that are like you're talking about the API, right? I mean,
Was that the spec or the API? That was the spec.
no, spec. Spec. Xing has commented on the PR, and she said that yeah, we made the change to use name instead of what we had right now. So API. We fixed the API in the CAP, but we did not update the spec. So I need to update that.
You mean in the KEP? So the KEP has the updated API, but not the updated spec.
Correct.
That's what you're saying.
Yeah.
I see. Okay. Yeah. I saw the comment by Shing. I added a few comments too, but that seems like a fair explanation. do you remember the reasons for putting the region? I mean, I think I remember the reason for putting region and zone as top level fields, because we checked the three cloud providers and we checked a few implementations of the S3 protocol, and they all had region and zone. So it made sense to put it as a top level field, correct?
Yeah, it kind of makes sense, but we haven't uh, actually made the decision. So
So I'm confused. So why is it already in the cap then?
I
It's not in the cap, right? That's why I was like, it's different. And
it's in the step. Yeah.
yeah.
Okay, so okay, let's quickly resolve this. Are we saying that we should have region and zone as top level fields in the spec?
Uh, is it
So
common to
I'm
all?
wondering if that's too specific. What if like you also have rack or something? Maybe want to take a look over the like the topology, you know, how that is added in the CSI, because because it could be many different ways to specify.
So region and
Topology.
zone are yeah, these two. So
Not
region,
necessarily. It could be some other names. It could be like rack. If you do, I think I suggest you actually take a look of the topology.
CSI, yeah.
Topology
Um,
and CSI, yeah.
yeah, yeah. So you're saying make it more generic.
Yeah,
So
this then yeah, then this may not cover other ways to specify this. So I don't know if this is a, you know, this may not be.
yeah, in object storage, what happens is I can actually see that topology thing. So let me think about this. Um, yeah, you're right. So because you could get a create bucket request for a local object storage provider or something like that. Say, yeah, that's fair point. That's a good point. We never thought of it that way. Hmm. I don't know how important this use case is. So to everyone here, Shing just brought up a great use case, and again, from from Minio's perspective, we have some deployments where, like especially with like web scale companies, where they have multiple clusters of Minio, each on a separate rack, and some set of workloads are configured to talk to the MinIOs on the closest rack, for instance. Um, and so one of the ways one of the big customers do it is um, they have three different Kubernetes clusters, one for each of the racks, and they just route their applications to talk to the one MinIO service inside their Kubernetes cluster. Now, with something like topology awareness, we can specifically tell the system to provision a bucket uh, from a particular topology and not have to deal with the overhead of managing multiple Kubernetes clusters, like in this case. I'm sure there are different solutions for this problem, but I think topology would be one way of addressing this. Now, my question is, can anyone think of, like, what do you all think about this solution? Like, what do you all think about having a topology as a top level field on bucket specific operations?
I think it's a good idea. Also from cloud's perspective, there's more than just regions. So
Well, there's regions and zones, so that's why we added those two.
I think it needs
Why
to be more generic.
I, I totally agree with like region and zone is too specific, and you want, you know, just a generic thing like we have with CSI.
Mm-hmm.
And I think that's not controversial. But when you say top level field, like of what? Why wouldn't it be like of the bucket class or the bucket access class? Like why would it be of the specific object? That's the piece that's confusing me.
Oh, it's not. So, what do you mean by specific object? Do you mean?
I don't know exactly what you're proposing. So I heard you say like it should be associated with every object, and I'm like, oh wait, this feels like a class thing.
Oh, so sorry, I wasn't. Yeah, it is a class thing. So I was talking
Okay.
about bucket operations. I wasn't saying specific object, but bucket operations.
Okay.
So
So top level in the class, that was the top level.
So right now it is actually in the create bucket, right? It's not the class right now. This one is. Are
yeah,
you?
this is the gRPC spec, but from the API, it will come from the class ideally.
Oh, okay. Then you basically.
And not from the parameters, not from the map, but as a top level standalone fields, right?
Right,
Mhm.
right. And we can design this to be exactly like topologies. Any user defined or provisioners defined keys and values.
I think if it makes sense to that region and zone will be implemented as layers in these topologies, then it just we just want to make sure that this kind of use case works, right? But other than this, I think more flexible ways of defining these location constraints, or I don't know, in AWS, I think they called it location constraints.
Oh yeah,
When you create a bucket, right? Or you do a head to a bucket, you get a location constraint back, something like that.
Oh, I see what you're saying. So, so in case of CSI, so there are some differences here. One is, this is over the network and not locally attached, or it's not, the volume is not attached to a particular node.
But maybe
So
this is the intent, right?
could be. So do you see that as a use case where you have a particular deployment of object storage that is only intended for a particular set of clients, like only intended for rack one, say?
You may have a preference there. It's not necessarily a restriction, but at least a preference that the workload that accesses the object storage sits close to the actual storage.
Yeah.
But that's the inverse of what this topology is about, right? This is about provisioning. The other one would be once something has been provisioned, where do we put the workload?
Yeah, I think both kind of go. So what do you mean by inverse? To me, it seems like they go hand in hand.
You start with the class and then copied to the bucket, right? Like this
Take
configuration.
brownfield.
So do you mean that when a workload requests? Okay. So are you saying when a workload requests a bucket, we respond saying these are all the nodes on which you can run?
Possibly.
Okay. Do we want to design it like that? It's an honest question.
I think it's two distinct topics. One is about where do you want to provision. The other one is once provisioned, greenfield or brownfield, from where can you access it?
Right.
That's a great point. So
yeah.
having affinity for access is an important output of a provisioner to the scheduler, right?
Yeah.
Yep.
So okay. To start with, I think we should. I'm for having this kind of generic topology constraint for the provisioning itself, provisioning of the bucket. In terms of access, I'm just kind of worried about the complexity of doing this, because on one hand, it's possible to achieve this kind of constraint by setting some kind of affinity rules on the pod and saying that the bucket is accessible from anywhere. So as far as the bucket is concerned, it's a network endpoint. So any pod running on any machine can just get access to the bucket. Could be a good start.
You're saying that's the default, not the. not the way it always works.
So like if you look at policies on a bucket, they're never based on the client that's going to access them.
Right, but the administrator could know that the location of the bucket is on a machine that's behind a firewall and can only be accessed from some network subnet.
So we're looking at multi-tenancy case, right? Where you have an admin serving two workloads and want to segregate them, two nodes maybe, and also the buckets that they
Right.
use. Right.
I think that's what he means.
Well, I mean, that could be the case, but it could just be the case that, you know, due to your network topology, that you don't have universal reachability, and you know, for who knows what reason, and you just have to reflect that fact back into the system so that the system can make the right choice.
And so in Kubernetes, is there generic networking abilities to define these, or
that's what the topology is. It's like key value pairs that say, you know,
for
if it's in the
CSI,
same,
you mean? The topology for CSI. Okay.
yeah,
And
yeah.
that
If it's in the same region and
mechanism.
zone, they presumably have reachability, and if they're not, it may or may not have reachability. And that's actually one of the things you can get out of CSI is you can say, I prefer it to be in zone A, but as long as it's in a zone that I can reach from A, I'm okay, you know.
But I wonder for the practical reasons that I think Sid mentioned before of complexity, is there anything like, is there any control flow in CSI that will take this topology and, you know, we can just reuse and, you know, get the same effect on the pods and affinity and all that?
Yeah, yeah, oh yeah. I mean, in your storage class, you can put like a topology and it will be sent down to the CSI provisioner. No, the CSI provisioner, if the provisioner has the topology capability, and then if the provisioner says that it has the topology capability, then it must respect the requirements that the provisioner passes in, or fail if it cannot. And then additionally, after it needs to tell, you know, if you give it multiple choices, like say put it in A or B or C, it has to tell you which one it actually chose.
Well, actually, no, it tells you first, out of, say, you give it 10 nodes that you can run on, and then it responds saying you can run on any 5 of these 10 nodes. And then the scheduler goes and then chooses one of the 5.
You're thinking of the bind on first use or wait for first consumer behavior?
I'm talking about the provisioner, the CSI controller, which gets create volume.
Yeah. So there's two ways it can work. One is you can have an explicit topology set on the storage class, in which case every volume that uses that storage class will get those topology constraints. And the constraints include both a hard list of requirements and a soft list of requirements. So the hard ones must be satisfied, and the soft ones you prefer to satisfy. But you can also set a behavior called wait for first consumer, in which case it doesn't provision the bucket, or not the bucket, the volume at all until somebody binds to it, and then it waits for that somebody to be on a node. Then it takes the topology of that node and says, please put it here, so that you're guaranteed that the volume is as close to the pod as possible. Those are the two ways that you can work with volume topology. So it feels like we would want the exact same behavior out of buckets, I think.
It does, yeah. So again, so let's say we want the exact same behavior. I'm thinking about this in terms of implementation and how we want to plan this. How does this sound? And I'm open to ideas. So I think to begin with, we only focus on the topology constraints while provisioning. To begin with, once we have that down, I think once we have our agent in the kubelet, I think then we can talk about, we can get into the scheduling based on topology constraints.
Scheduling of what?
Scheduling of workloads that are going to use buckets from a particular, buckets of a particular type.
Well,
So
yeah,
you mean
so,
you first want to affect the bucket creation and pass on the information about topology, right?
Mm-hmm.
But you don't want to handle the bucket access piece where you need to affect the pods and integrate all the actual logic that will take information about this topology from the bucket to the access, right?
Right.
Or maybe the bucket access. I'm not sure if like bucket access. I mean the class. Not sure.
Yeah. So
There's
another
some design
argument,
work here because we have somewhat of a different and like another model for access, which CSI doesn't really have. So we need to think
yeah,
maybe what does this mean.
yeah. I was gonna say like it's not clear how the access plays into this, because that's a new thing with Cozy.
Yeah, maybe they just need to be matching in the simple case, or maybe maybe they.
Or maybe the access has no notion of topology whatsoever, and all the notion of topology just comes from the bucket.
Yeah.
Because why would the access have anything to do with topology? Like it is where
because
it is.
that's I'll tell you why. That's kind of a back. So it will be a feedback loop that allows you to not only specify where the bucket should exist, right, when you create it, but it should also tell you where you should be, spinning up your pods so that it will be accessible now.
Right, but you can always get to the bucket indirectly through the bucket access. So
What do you mean indirectly?
You've got a pod. It refers to a bucket access request.
Yeah.
The bucket access request has to refer to a bucket request, and from that you can get the topology information. So like it's just a pointer, another level of indirection, but you can still get to the bucket request in the bucket and the topology information.
Oh, so your question is why would I ever define a different topology for the access versus the bucket and not
right?
Okay,
Right. Like so
yeah.
the bucket is where it is, and however many accesses you add, it doesn't change the fact that the bucket is where it is. So so what you're interested in is where the bucket is, not any aspect of the access.
And how do I map the topology of the bucket to the topology of the pod that will use it? Is there like they should match?
Yeah, they're required to, so at least in CSI, they're required to have the same universe of keys. So if you're running in Google Cloud, you get region and zone. If you're running in, your homebrew cloud, it's your homebrew keys. And
Okay, so maybe that's what, like this kind of specification, I'm not sure how to define it, but that should be in the bucket access. Like what is the priorities or what are the levels or something about the
that would go in the bucket
something that
request, right? Not would go in the bucket access request or the bucket access class.
Yes. That means like information about how to parse and the topology and apply that to pods, right? Because there might be some, but well, maybe not, but we might have something like that in the class. But you're saying not the topology again, right? That's I understand.
Yeah, I buy that argument. That is, we might have different ways to access the same bucket within the list of allowed machines it can run on. And that could be encoded in the bucket access class.
But that would, I get the different accesses, but how does that play into topology? I'm just...
So for instance, my bucket is available to the entire Kubernetes cluster, but then the high throughput storage applications get to go on rack 1, but everything else can run on anything but rack 1. That kind of logic.
Yeah, but but play it through. So you either have a bucket class that says put it in rack 1, in which case the provisioner either can or cannot do that, and if it can, it will say so, and if it can't, you'll get an error. So somehow it ends up on rack 1, or you have no bucket at all.
The bucket is actually accessible from both rack 1 and say rack 2. It's just the rack 2 applications treat this as data that doesn't have to be high throughput. It can
That's the sort of the multi-tenancy, or
right.
separate workloads
yeah.
into different
For the same
SLAs.
bucket.
Exactly.
So with CSI, what you would say is the bucket is in rack 1 and it's accessible from all racks. Like,
No, we're saying the bucket is accessible from all racks anyways.
Yeah.
There are some
Yes.
applications that need faster access to the bucket, and there are some that don't need it.
But that
bucket.
so what you do is you arrange for the bucket class to say hard requirement, it has to be in rack 1, hard requirement, it has to be accessible from everywhere. Soft requirement, it should be in rack 1.
Yeah, so but if I want to guarantee that an application always goes to rack, this particular application always goes to rack 1, and another particular application never goes to rack 1, I can't do it with that.
But that's done outside.
They will
of
have
bucket,
different
right?
buckets then. In our
That's
case,
for the
that's
same
a pod
bucket,
scheduling
for the
thing,
same
right?
bucket.
No, but they will have different bucket entities in like the cluster scope buckets, right?
Mm-hmm.
And I think what Ben is saying that, like, our bucket access is mainly representing credentials maybe, and less of the the physical aspect of access.
Right, I'm saying I can see a case like you mentioned, Guy. I can see a case where bucket access class or bucket access should have some notion of where they want this access to be provisioned, where the workload that uses this bucket access should run.
But you're talking about the pod scheduling, and like Kubernetes has ways to ensure that your pods end up in the places where they're supposed to be. So like if you happen to know that rack 1 is the high performance rack, you can arrange for your pod to be there. And and that's a solved problem today. Like the only new problem is, how do you also ask for your bucket to be there, assuming that it could be other places, and then get feedback from the system that it either did go there or that it couldn't for reasons, So the key is that you have a way to express the hard requirement that I want it to be accessible from all the racks, period, no matter where it actually ends up. And then the soft requirement, I prefer it to be in rack 1 because I know that'll make things go faster.
I think that's I agree that this is how you do it, like an admin, right? You would take and start administrating everything and making it right. But on the other hand, what we're saying when we allow the Cozy to apply these affinities, right, is that suddenly we allow automation from Cozy's side to the workloads, where maybe the workloads are not, they don't care, right? Maybe the administrator does not wants something to automate access based on access requirements. So I think that's the use case.
So a user could say, here's my bucket class. It's like fast access class. Or another user could say slow access class without manual admin intervention each time.
I'm really not comfortable with the mixing of the different sort of paradigms. I think the access classes were really about like credentials and authentication and
I'd say that in CSI, in CSI it's less
evolved,
right? Because like sharing the same resource behind.
Yeah, it is.
But
maybe this is where it comes from.
Where I'm getting stuck is like, once the bucket is created, like whether it's fast or not is predetermined, right? You can't change it by creating an access class, right? Like once it lands in rack 1, it's going to be it's going to be fast for the guys in rack 1, and it's going to be slow for the other guys. And nothing you can do with access classes is going to change that fact. And like, and if you want to put it in rack 2 or have another bucket that's fast for the rack 2 guys, then you can provision another bucket and ensure that it ends up there. The only thing that Kubernetes is going to care about is like, can I attach to it or not? And then if I want to be close to it, where is it, so I can pick the same place, right?
Yeah.
Those are the only two things that you.
So how do you set the second one? Yeah.
So the second one.
Just where it is. And
part
then
of the CSI spec is when you do any kind of topology-based provisioning, it has to tell you which one it picked. So,
Yeah.
so you can say, it needs to be accessible from everywhere, but I prefer it to be in zone 1. And it can say, well, I couldn't fit it in zone 1, so I put it in zone 2. And then you're like, now you know it's in zone 2. And if you want fast access, you schedule to zone 2.
who does? I mean, like
the admin.
yeah. So what I'm asking is that I would have to apply these topologies or affinities on the workloads to make that happen as an admin, right?
Yeah, that's what we're saying right now.
So yeah, I see what the concern is. So with CSI, I don't think you can just like make the pod follow the volume. I don't
Yeah,
believe
right.
that is
That's
possible.
my question.
But you can
Yeah.
make the volume follow the pod by setting the volume to like wait for first consumer, and then it lets the pod get scheduled first, and then it tries to put the volume.
Again, I think it's a matter of use cases. I think follow the bucket is more common than follow the volume, maybe.
Right,
Right?
but you're talking about changing the Kubernetes pod scheduling behavior, which
Right,
feels
right.
out of scope for what we're responsible. Like we are not going to go change how the pod scheduler works as part of Cozy, right? It would be nice if it were possible to do so, but that's not our job. Our job is just to provide the information so that the guy who wants to modify the pod scheduler has all of the information available to do that.
Okay, so few things.
But so I don't mind. I mean, I think it's okay to leave this out, but I'm kind of questioning. We are injecting information into the pods, right? We are getting into close encounter with, setting the pod's information to work like was intended by the provider, right? So I would say, I mean, I'm not saying it's, it should be inside or not, but it's a gray area. That's where I'm thinking it is.
I mean, the other thing to bear in mind is like schedulers are entirely pluggable in Kubernetes anyways. And like if someone is using anything other than the standard scheduler, then it kind of doesn't matter what we do because it's going to get ignored.
Yeah.
I really feel like pod scheduling is out of scope, and we should make sure the information is reflected into the object so that if someone wanted to write a scheduler that took that information into account, it would be available to them. But that's sort of where we stop.
That makes sense.
I think
that makes sense.
And
good.
And the last thing I'll say is like that's the bucket, not the access, right?
Right.
You know where the bucket is. You tell it. You put the information on the bucket object, and then a scheduler has access to that information if it wants to make pod scheduling decisions based on it.
Right. So the last point that you said is what I wanted to reiterate. The way you can access the bucket from is on the bucket itself.
And maybe we can have like a preferred topologies on the bucket itself as well, so that you can express the fact that it is accessible from everywhere, but it's faster in zone 1 or rack 1, whatever you call it. And then if someone wanted to write the scheduler that says put the pod in the fast place, the information is available to do that.
Yeah, that makes total sense actually. I think we should flush this out a little bit more. The first question I still have, though, that we don't have an answer for yet is how much of this do we really need? And I'm doing this exercise as a way of making sure. Let me put it this way: if we add a feature, removing it is going to be very, very tough, rather than having less features to begin with and adding them as we go forward. So I just want to do this exercise once of how much of this do we really need, and if there is something we can cut down, what is it? So right now we've run out of time, so let's do that on Thursday. But that's something we should definitely discuss before we take on the full scope of this. That's it from me about this one thing. I did want to give a conclusion on the discussion from the last few weeks about credential mounting. I think we reached a good conclusion. I just wanted to make sure everyone is aware of it, but I'll do that on Thursday again. Other than that, I think that's it from my side.
Cool.
Is there anything else someone wanted to bring up? Okay. Okay, great. Let's chat again on Thursday. I'm glad, Shing, thanks for the suggestion. I think we started a good discussion, and we'll take it forward as we go.
Sounds good. Thanks.
Thanks, everyone.
Thank you.
Thank you, everyone.